Hi, my name is Rachel Slosky. I will be going over an FE, or Fundamentals of Engineering example problem. The problem is as follows. An engineer is buying a piece of equipment to use over a 10-year period and then sell it. The equipment costs $25,000 and generates an income of $8,000 a year. At the end of this 10-year period, the engineer sells the equipment for $3,000. With a discount rate of 3%, how much money will be made or lost? In order to complete this problem, I will go over the following concepts: cash flow diagrams, present value, discount rate, and time compounded. The formulas needed are the present value formula, presented here, and the uniform series present value. Here, PV stands for present value, FV for future value, N for number of compounding periods, and R as the discount rate. Now, I will solve the problem using the concepts and formulas previously presented. Also, here's the problem statement for reference. I find the easiest approach to any problem is first seeing what the problem gives you. In this problem, the initial cost of $25,000 is given, the future value of $8,000 is given, and the rate is given as 3% or 0.03 in numerical format, and N is 10. First, we're going to create a cash flow diagram. The downward arrow indicates the amount spent, or $25,000. The upwards arrow indicates the incoming cash. Yet, I know it's a little bit backwards. The $11,000 indicates the income, composed of the $8,000 from the amount of incoming cash and the $3,000 from selling. Now, we will draw 9 lines between the two end lines. These 9 lines are the income amounts of $8,000 between the initial year, where the $25,000 was invested, and the final year, where the equipment was sold. There are actually 10 lines for the compounded time of 10 years. For the calculations, these are the 2 equations that will be used: the uniform series present value and the present value equation. First, start off with the uniform series present value formula, the first one listed. 8,000 is a future value, 0.03 is a discount rate, and 9 is the compounded time for this part of the equation only. In general, the compounded time is based on the actual time of the payment, not the number of the payments. The next part of the equation is actually based on the basic present value formula, representing the final 10th line on the diagram, where 8,000 plus 3,000 equals the 11,000. As this is only occurring the 10th year, we will use 10 as the compounding time. Addition of the formula based on the 9 compounded years and the 10th compounded year equals 70,747. However, this is not the final answer because we need to subtract the initial cost or investment of the $25,000. This will give us $45,474 as the net present value, our final answer.